Let's graph some more complicated things. A couple of terms to get straight here. Sketch a function. It will show a graph's general shape and its key features, those key features being maximums, minimums, x-intercepts, y-intercepts, asymptotes, things that we've been finding all along. If we're asked to draw a function, it should be done more carefully, and we need to put an accurate scale on our graph, and points should be plotted where they belong. So if the point is 1, 2, and the next point is 2, 8, things should be evenly spaced across the x-axis and y-axis. You have to be just a little bit more careful when the directions say to draw a function. Sketching can be quicker. So here we go. Y equals 2 to the x over x minus 2. Ooh, that is not one of these other ones. I mean, it's exponential. It's also reciprocal, but ew. The nice thing it says use technology to help answer the following questions. So we want the axes intercepts. We want the turning points, maximums or minimums. Find any asymptotes. State the domain and range. Sketch the function. So sketch. So I actually don't need this coordinate plane unless I really want to. And I always like to use the coordinate plane. I always like a scale on my axes just to make sure that I'm putting points in the right spot and it looks right. Unless the graph is really, really big x and y intercepts, then I go away from it. So here we go to our calculator. And I already punched this in. There's our function, 2 to the x over x minus 2. This is what it looks like. Sort of looks like the reciprocal graph. And if you notice, it sort of looks like the exponential graph. I mean, it sort of looks like, oh, that wasn't what I wanted. Sort of looks like, that's sort of 2 to the x. Horizontal asymptote, we needed that, didn't we? So, let's look at this, over x. What does that tell us? It tells us that x equals 0 is undefined. And if we look at the graph, it certainly looks like there's a vertical asymptote there. So vertical asymptote at x equals 0. Good there. So that means that there's no y-intercepts. Now, let's find the x-intercepts. Looks like we can tell what they are. Remember, we can always look at a table. Oh, look at that. This tells us very clearly that x equals 1 and x equals 2 are my x-intercepts. So x-intercepts at 1, 0 and 2, 0. Lovely. I forget, what else did we need? Axes, intercepts. Okay, we need turning points. Turning points. That's minimums and maximums. I'm going to hide my table. And now it looks like there's only a minimum, and it's right here, somewhere between 1 and 2. To find that, analyze graph, minimum. And there we have it. There is our approximate minimum value for this function. And we should be writing these things down on our paper so that we can transcribe them onto the graph that we create. Domain. Set of x's such that x doesn't equal 0. X can be anything else, just not 0. Range. Is it all real numbers? There's a big question. It's not all real numbers because there's actually a horizontal asymptote that we didn't mention here. There's a horizontal asymptote at y equals -2. And we could see that if we go back to our table and go to negative x values, we'd see that we're getting really, really close to -2. So let's sketch this graph. -2 has an asymptote. There is also an asymptote at 0. And because it's a sketch, I just need to draw in this branch over here. I don't have to be real careful about what points I go through. If it asked me to draw the function, I would need to make sure that it's going through the proper points. And I could get those from the table. Now this other side, we had intercepts here and here. We had a minimum of 1.44, comma, I forget, -0.116. And you should always label those points. And here comes the graph down through the intercept, hits the minimum, back through the intercept, and off it goes. There is my sketch of the function. I have my key features labeled. I give the equations of the asymptotes, and we are done. One more graphing example. Draw the functions y equals 1 over x. Okay, we did that in the previous video. And it looked like this. And again, if you don't remember how to graph something like this, make a table. Practice graphing these with no calculator. So this is y equals 1 over x. 2 minus x, that's something we should be able to graph. It has a y-intercept of 2, slope of -1. And because it says our domain is -4 to 4, our graph will stop at -4 and +4. We don't have to graph anything further than that. So, hence, find any solutions to this equation where they're equal. Oh, well, we can look at the graph and actually see that the solution is x equals 1. It's the intersection point. We could solve this. We could multiply both sides or everything by x, and we get 2x minus x squared equals 1. So then x squared minus 2x plus 1 equals 0. And then we have a quadratic that we could solve, and we end up getting a factorable quadratic that is a perfect square. So x is 1. And that's what we ended up here visually. Now C says on the domain for the real numbers. So now this could be any value of x. For what value of k will we have one solution, two solutions, or no solutions? And this is talking about types of solutions, not actually what they are. And notice we had a quadratic in part B. So types of solutions when there's a quadratic involved. Discriminant, anyone? Does that ring a bell? That term, discriminant of a quadratic, tells us what type of solutions we're going to have. So x squared plus 1 over x equals k. I'm going to multiply everything by x. Not x squared, regular x. Multiply everything by x, we get x squared plus 1 equals kx. X squared minus kx plus 1 equals 0. Remember, discriminant is b squared minus 4ac. So here we have negative k squared minus 4 times a times c. And a and c are both 1. Now if there's one solution, that means that the discriminant equals 0. So let's deal with that. One solution equals 0. So k squared equals 4. K could be positive or negative 2 and have one solution. Two solutions. That's when the discriminant is greater than 0. So solving this, we get k squared greater than 4k greater than plus or minus 2. And I always get confused with inequalities and quadratics and square rooting and all that. We should probably go to a sign diagram. Put our zeros on and test a value. Let's test 0. 0 squared minus 4. Well, that's negative. And that means that these two parts have to be positive for the discriminant. So when there are two solutions, k can be greater than 2 or k can be less than negative 2. And it follows from that this stuff should all be for two solutions. Uh-oh, what'd I do? It follows from this that when there are no solutions, the discriminant is less than 0. And from the sign diagram, we see that that happens when k is between 2 and negative 2. So pulling in some current graphing skills as well as some old school quadratic stuff to this wonderful, beautiful problem.